Cleaning is something we all understand because we all do it at home or at work. We use detergents and disinfectants, then apply an appropriate amount of elbow grease and assume that the cleaning process has cleaned clean. Normally, the effectiveness of virtually all cleaning, whether domestic or industrial, is assessed visually. Manufacturing areas basically and equipment does it clean to remove previous products and other contaminants to prevent cross-contamination, that is, where one substance or product contaminates another. In an ideal world, the cleaning process would be completely effective and everything that's been cleaned left without any residual contamination, either viable or non-viable. In practice, this is difficult to achieve, not least because there are physical limits to the removal of very small, often molecular-sized particles, and no less relevant. So, validation must prove that cleaning will have neutralized or removed all traces of possible contaminants, including the detergents and disinfectants, even or especially when the surface appears to be visibly clean. We must accept that while the objective for precision cleaning is to remove all contamination, the fact is that in practice it's unlikely to do so, and the traces that remain after cleaning function of the cleaning strategy is to establish and document the acceptable and therefore safe quantities of any residues left after cleaning. It must establish how, what, and from where samples for residue tests are to be taken, and it must specify how these samples will be assayed, how they'll be examined analytically, and how results will be interpreted. An important strategic factor is to decide when cleaning validation is to be performed. That something introduced into the production environment during cleaning and/or testing is potentially more dangerous than the residues left by the substances being cleaned in the first place. Remember, cleaning is done by people, and its effectiveness is dictated by their ability to follow the standard operating procedure. In fact, we saw training and cleaning is unlikely to produce absolute cleanliness, and residual limit is the term given to the amount of any matter that may be left on a surface after cleaning, which will not impact adversely on the next batch made on the same equipment. The wide range of cleaning parameters to be considered within the plant as a whole, within each department and for each item of equipment, dictates that specific locations are the subject of individual studies. There are a number of the active ingredients that must be studied. Other materials to be considered include excipients, cleaning agents, and sometimes even breakdown products, because even if a substance is harmless in one combination, it may be a hazard in another. The toxicity of relevant substances and the ability to analyze the contamination, the residues, in a form which is detectable by the analytical methods of choice. That choice will depend on the sampling site, the nature and properties of the residue, and the type of facility and its equipment are the same as those used normally to determine the content of active ingredient in the finished product. In many cases, the technique used to